We're going to be solving quadratics by completing the square. Up until now, you've solved all of your quadratics by setting the quadratic equal to 0 and then trying to factor it. And sometimes factoring is easier than others, but we're going to look at a new way, a way you can use instead of factoring, or you can use when you can't factor the quadratic equation. But first, I want you to take a look at a couple things we've already solved where we're using a different method to solve a quadratic equation. So we have the quadratic equation x squared equals 5, and we can solve that just by taking the square root of both sides. We don't have any other x terms, and so we can take the square root pretty easily of both sides, and we get x is equal to plus or minus the square root of 5. So that gives us two solutions, x equals positive square root of 5, and also x equals negative square root of 5. Now if our quadratic is written as a perfect square, we can also solve it by taking the square root. Here we have x plus 7 squared is equal to 2. We can just simply take the square root of both sides. So we get x plus 7 is equal to plus and minus the square root of 2. And then if we subtract 7 from both sides, we have x is equal negative 7 plus the square root of 2 and negative 7 minus the square root of 2. So we already know a little bit how to solve it. As long as it's written in these special forms, we can solve a quadratic equation without factoring. But what if, like in this case, it's not written that way? What if it's written like this and we've got to figure out how to manipulate this equation in order to form a perfect square? Because we know if we have a nice perfect square, we can take the square root of both sides. Now again, this is algebra. We like to manipulate things in algebra. So we'll be manipulating this equation so that we can find a perfect square in there. So the first thing we want to do is get it so that this side is going to look like a perfect square. We're going to add 10 to both sides here. So we've added 10 to each side, and we have x squared plus 4x is equal to 10. Now we would like to add something over here to make this a perfect square. If we add something to this side though, remember we also have to add it to this side. Otherwise, our equation is not equal. We don't have an equal amount. We do not have an equation. So whatever we add to this side, we need to make sure we add it to this side. And it'd be nice and handy if we could figure out what was going to make this a perfect square. Well, now the way you do that is you take half of whatever this is right here. You're taking it in half. So 1/2 of 4, we get 2. Now we're going to square it because we need this to be whatever it is squared. And then we're going to add it to both sides. So 1/2 of 4 is 2. Half of this is 2. And then we're going to square it and add it to both sides. So this is 2 squared plus 2 squared. Now that gives us a complete square. This gives us a 4 right here, and we can factor that. We know that's a perfect square. So we can factor that into x plus 2 times x plus 2, and then this is just 4 right here. So x plus 2 times x plus 2 equals 10 plus 4, which is 14. So now we can rewrite this as x plus 2 squared. That's equal to 14. It's written exactly how I like it in order to solve it. Take the square root of both sides, and we have x plus 2 is equal to plus and minus the square root of 14. We're going to subtract 2 from both sides because we really want to know what x is equal to. And then we get x is equal to negative 2 plus and minus the square root of 14. We have two answers there. We have negative 2 plus the square root of 14 and negative 2 minus the square root of 14. These are going to give us two numbers that are solutions to this equation. Now notice we really can't factor this nice and easily. And so it's great to be able to have a way that we can solve this equation, this quadratic equation. Let's look at another example so you can start to get an idea of where we're going. X squared plus 6x, or x squared minus 6x minus 12 equals 0. We also can't factor this. Two numbers are not going to multiply together to give me negative 12 and add together to give me negative 6, so we can't factor this. So we're going to use our method of completing the square. First, we need to have a perfect square on this side, so we're going to get rid of all of this stuff so that we have room for a perfect square. So we're going to add 12 to both sides. And so we have x squared minus 6x, and then we're going to add something here. We're going to add something to make that a perfect square. And so we do 1/2 of -6, which gives us a -3. And then we're going to square it because it's got to be a perfect square. It's got to multiply to give you this, add together to give you this. And so we square it and we get a 9 right there. And then 12 plus a -3 squared. -3 squared is -3 times -3, so it's going to give us a +9. So we have 12 plus a 9 right there. We can factor this now into x minus 3 times x minus 3. That's equal to 21. That's 12 plus 9. And then we can rewrite this as x minus 3 squared equals 21. Take the square root of both sides. And we have x minus 3 equals plus or minus the square root of 21. We want to know what x equals, so we're going to add 3 to both sides. And we get x is equal to 3 plus and minus the square root of 21. Remember, that gives us two answers. X equals 3 plus the square root of 21, which is a little less than 5. So that's going to be a nice positive number, a little less than 8. And x equals 3 minus the square root of 21. That's actually going to give us a negative number because this number is going to give us a number bigger than 3. So we've got two answers in there for our quadratic equation. Now where it gets a little bit sticky is when you have a coefficient or a number in front of that x squared term. So say we have 3x squared minus 12x minus 5. Again, can't factor it. And so we're going to try our new method of completing the square. Before we do that, we're going to divide everything by 3 so that we have a 1 coefficient in front of the x squared. So just go ahead and divide through by 3. 3 over 3 is going to give us a 1. Negative 12 over 3 is a -4. Minus 5/3 equals 0 over 3, which is just 0. Now we can go on with our same method. We're going to add 5/3 to both sides so we can leave room for our perfect square on this side. So plus 5/3 plus 5/3. And we have an x squared minus 4x plus, we're leaving that blank, equals 5/3 plus. So we're going to add something to make that a perfect square. Well, when we look at this, we take half of -4. Half of -4 is going to give us a -2. And then we're going to square it and add it to both sides. So we're going to add a -2 squared, which is just a 4, plus a -2 squared. Okay, so now we've got, if we factor this, we've got an x minus 2 squared. X minus 2 times x minus 2, x minus 2 squared. Now 17/3, so we have 5/3, and this is 4 right here. -2 squared, -2 times -2 is a 4. So we have 4, and I like to think of that as 12/3 because then I can add it to this third. So I have 5/3 plus 12/3 is going to give me 17/3. Then what I need to do is to go ahead and take the square root of both sides. And when I do that, I get a positive and negative root. And then I have x minus 2 is equal to the square root of 17/3, plus and minus 17/3. Going to add 2 to both sides, and I get 2 plus and minus the square root of 17/3. And it's okay to write it like this, but I want you to realize that those are two different answers we could plug in there. We get a total of 2 solutions to this quadratic equation. Okay, let's look at one more example. Having a coefficient in front of that x squared. That seems to be the biggest tricky point. So, and also we notice this is not set equal to 0. Sometimes you'll get equations like this. And when we were factoring, we would always set it equal to 0, but when we're completing the square, it actually makes it a little bit easier for us because we already have that blank space right there that we can use to make this a perfect square on this side, and we've got the 5 over here. But the first thing we always want to do is divide by that coefficient in front of the x squared. So divide that by 2, divide 6 by 2, and divide 5 by 2 to make sure it's equal. If we only divided one side by 2, this wouldn't be an equation anymore. So we need to make sure we do that to both sides. 2 divided by 2 is going to give us a 1x squared. We don't have to write the 1 there. It's just implied because there's just 1x squared sitting there. Plus a 3x, 6 divided by 2 is 3, equals 5/2. Okay, so now we have to half this, take this in half, take 1/2 of 3 and square it. So 1/2 of 3 gives me a 3/2, and I kind of do this off to the side when I do these problems, just because I know what I'm adding here is not going to be this. It's going to be whatever half of that is squared. So then I'm going to go ahead and add 9/4, and I have a little 9/4 right there because I was adding my fractions. 9/4 to both sides. And I could have written that as 3/2 squared. It's the same thing. 9/4 is the same thing as 3/2 squared. So then I have an x plus 3/2 squared. It's whatever half of this is. That's what's going to make this, because it's got to add together to give this and multiply together to give this. So x plus 3/2 squared is equal to, I wrote 5/2 as 10/4 here to help me add, plus 9/4. And that gives me a total of 19/4. I take the square root of both sides. I have the square root of x plus 3/2 squared equals plus or minus the square root of 19/4. Now when I have this is the same as the square root of 19 over the square root of 4, and the square root of 4 is 2. Let's go ahead and simplify a little bit. So I have the square root of this squared, which is just x plus 3/2, is equal to plus and minus the square root of 19 over 2. I took the square root of that 4. Going to subtract a 3/2 from both sides, and I get x is equal to negative 3/2 plus or minus the square root of 19 over 2. That's 2 solutions to our equation here. And now that you know how to complete the square, your life is complete. And we can actually use completing the square to come up with a formula so that we don't have to complete the square every time.